A little bit about myself. I'm Jeff Cote with Pacific Yacht Systems. Big passion for boating. I mean, if I had to describe myself in one word, it'd be a boater. Some of you might care to learn more about this topic. We write 2 columns every month, one in Pacific Yachting, one in Northwest Yachting. All those articles are actually published and available for download on our website for free. They're all up there. You can find any article that we've ever written ready for download, so you don't need a subscription. As a boater, I'm a big fan here in the Pacific Northwest of going a little further afield. And in the summer, that means being in places that aren't all that warm. As soon as you pass sort of a place called the Discoveries, right, past Desolation Sound, it goes from summer to spring or fall instantly within 10 nautical miles. 5 nautical miles, the water drops in temperature from mid-70s to low 50s, and suddenly the weather pattern is completely different, even in July or August. And so as a boater here in the Pacific Northwest, having a heating system is a way for some of us to go in places where it's not warm, and it might be the shoulder season, it might be the winter, or it might be summer further north or on the outside of Vancouver Island. I was on the outside of Vancouver Island in the summer. Most of the weekends I was there. In Port Alberni, it was 28 degrees, and in Tofino or Ucluelet was about 15 degrees. There's almost a 15-degree difference between inland temperatures and outside of Vancouver Island temperatures. There's no summer there. I mean, there is, but it's not insane heat. So we were actually turning on the heat in July and August on the outside of Vancouver Island to take off a little bit of the cold in the morning and sometimes even at night. Our business specializes in electronics, and heating systems. We do servicing and installs here in the British Columbia, just because of distances and the border. And we got invited over 1,000 boat projects last year. Really proud of that. So the team made that happen. And we also do a lot of design. That's our fastest growing product line, is doing design for international clients, figuring out what they want, helping them make decisions. So we did over 200 of those projects last year. Now, one other important point, I'm a big believer in sharing, and we've got over 100, we're at right now today 165 videos on YouTube, and we're probably going to have another 50 within a couple of months. So we've got about 30 in the backlog. So if you're curious about any sort of these topics and you want to geek out, and you want to geek out in your own time and not just at a boat show, all those presentations are on our website and also on YouTube. All available, of course, and I chose to do no ads. I could have made a little bit of money with YouTube, but I thought it's such an annoyance and it's not worth it. So all the videos are without ads on YouTube. Realistically, when you're thinking and you've decided, and this is a good point, I mean, you've decided that it's going to make sense for you to do heating on your boat, and you're going to use a diesel-powered heating device on your boat, you really have 2 choices at this point. And I'll show you a slide that helps you make the selection, but you're really going to look at either hair heating. So you're kind of like using diesel, you're warming air, and then you're just pushing that air directly from the heater through ducting, big ducting, to a location. You can do that, but there's limits in terms of the boat size, and we'll talk about that. Or you're going to do sort of what's called a hydronic heating, where you're actually warming water, and via a pump, you're circulating that warm coolant water throughout the boat. And then you're taking the warm water and running it through heat exchangers, right, with fans on them that are blowing and converting, sort of like household heating back in the 1900s. There'd be a boiler downstairs, you'd send water throughout the home, you'd have radiators that would emanate heat. Same idea. The only difference is these heat exchangers throughout the boat are also going to have fans to help the air circulate, because we're trying to get a small radiator, effectively, maybe this big, and so we'll be blowing air across these pipes to send dry heat. And then the good news with hydronic is you can start having multiple of these heat exchangers far away from the heater itself. So we just did a boat just recently. An owner from Alaska brought his boat from Ketchikan, brought his boat to Prince Rupert, flew a team up to Prince Rupert, and we installed on a big 55-footer a big heater that had actually heat in the flybridge. There's 3 cabins, 2 heads, the salon. We even put heat in the engine room. So we actually put all these different heat exchangers, and we couldn't have done that with a forced air system. So at one point, there's an upper limit to a forced air system, and so that might be a reason why you're going to consider a hydronic heating system. So those are sort of 2 charts to show you how you go choosing a hydronic system versus a forced air. So the top section is hydronic, the bottom section is forced air, okay? And you can see that generally we end up doing forced air probably in the cuddy cabin, 25-footers, 30-footer, maybe 35-foot sailboats, right? But again, the problem is you might have the air coming out in the salon, but how are you going to have a heater installed in the aft lazarette, for example, and having ducting that's 3 inches or 4 inches pushing air all the way forward to a cabin in the V-berth? You won't. So in those situations, owners are compromising. They're saying, you know what, I'm okay in the cabin, we'll have sleeping bags, we'll stay warm, we won't get a lot of heat, and we'll have the heat from the cabin maybe sort of slowly emanating towards the cabin, but we're not going to have my own sort of heating outlet in the cabin up at the front of the boat. So those are limitations of the forced air, and every time you sort of put a Y or you put a bend, it restricts the flow, right? Because it's another bend, and that's going to slow down the airflow. So you just have to be realistic with a airtronic system aboard a boat, okay? Here's a little bit of a picture of what an airtronic heater, forced air heater looks like. I mean, at the end of the day, sort of what are the inputs? Well, one of them, first of all, is diesel fuel, right? So you need clean diesel fuel. So if your fuel is really lots of sediment in it, right? Or your tank hasn't been cleaned in a long time, and you're in really sort of bad seas, that can clog your fuel filter. We'll talk about that, but you need diesel fuel. You're also going to need battery power. Those heaters need some battery power to run, especially forced air, the blower, right? And with hydronic, you're going to need battery power to run the coolant pump, right, that circulates, and then to run all the fans. So there is an element of power consumption from running a diesel heater. The heat generation is from diesel, but the circulation of that heat throughout the boat is electric, okay? You also need a clean air supply input, right? So on some installs, we're actually going to take the air outside the boat, so that we're actually, and in some instances, we'll take it from inside the boat, but those are dilemmas that you have to ask, where am I going to get the air to run that heater, okay? Both for the combustion chamber and also for the source of air that's going to be, especially with the forced air, where that air is going to be blowing out. The output of that, besides warm air, is also the exhaust. There's an exhaust component, so you need to worry, and we're going to talk about how the exhaust has to be routed in a certain way, and where that exhaust, you're generally going to want to have it more at the aft of the boat. We'll talk about that a little bit too. So here's a little bit of a recap of what we saw. So the inputs are clean diesel fuel with no sediments. Even though there's a filter, the filters do get clogged if you've got really bad diesel fuel. Battery power, 12 or 24. Air supply, and then your outputs are warm air, and which is heat, and an exhaust. Okay, so those are sort of the inputs, outputs of a forced air system. Here's what an image of airtronic system looks like. We've got here on the slide on the top left, you've got the heater itself, and here just beneath it, you've got an exhaust. You can see all the different type of hose clamps. There's even a sort of a little drip here, drip loop at the bottom. So if ever there's condensation that builds up in the exhaust, it can actually drip down. You've got a double wall exhaust outlet, so that the outlet itself goes through and doesn't, you can see there's a little bit more thickness here than inside. So there's sort of an air gap so that your fiberglass doesn't get tarnished as it's leaving the boat. Here's the fuel pump itself and the orientation. We're going to talk about that a little bit later, but the orientation of the pump is very important. There's a filter on the inline, and then the out of this is very important. We'll talk about that. And there's also a fuel pickup, and that's the wiring harness. And that's the example of the ducting. So The challenge with a forced air heater in some instances is, where am I going to be able to run air ducting that's maybe 3 inches or 4 inches from the heater to the few multiple locations I've decided to have? Like maybe I want to run a defroster. I want to have one go in the cabin, and I've got a cuddy, like a 28-foot, fishing boat. I want one to go in the cabin, one to go outside beneath the feet of the operator, the driver. I want one to go inside the windows. I just want 3 outlets. That's reasonable, right? Not too big of a boat, makes sense. But the challenge is, how am I going to get 3 outlets from one unit with 4-inch ducting? There's not a lot of walls. This is not a house, right? There's not a lot of places that have 4 inches of space between the outside hull and the inside hull. So you've got to take those considerations before you do an airtronic system. You got to think about, how the hell am I going to route these big air ducts throughout the boat? In some situations, it absolutely works. In some other ones, it's just not possible. Even though you want to, you just can't do it. Okay, so we talked about the heater itself right here. We talked about the air ducting, the exhaust, which is right in the middle, the fuel pump, the harness, right? And what we didn't talk about was the thermostats. So there's 2 choices of thermostats, sort of an analog digital thermostat. Pretty straightforward to use, on off, and this is sort of the warmer, the further you go, the warmer it gets. Or you can actually have this one, which actually not only gives you dial in exactly the temperature you want, so you can say 72 degrees, but you can also have alarms and codes. Helps for diagnosing, figuring out what's going on. My heater's not working. Why is it not working? This thing is actually outputting error codes, and if you've got one of these analog thermostats, you won't know that. You'll need to have someone, a technician, come on board with the gear, or bring the heater to them, and they'll put it on the bench and they'll tell you what the issue is. Here's sort of the different types of hydronic heating. You've got basically the D2, D4 look like this. The D5 looks like this. There's a long formula, and I didn't decide not to share it. There is a formula in deciding how many ducting you're going to have and what the path is going to look like and what your bends are going to look like. When you do an airtronic system, hope is never sort of the best approach, right, in anything. So you want to take the time to make sure that it's realistic to have that heater not have too strong of a bend. I've heard recently that some heaters actually feel so much back pressure when they're blowing air that they're thinking that there's a problem, and they'll reduce the heater output by 50% because there's so many tight bends to get to the outlet, and there's so much back pressure that the heater's like, I can't output full capacity, and so the heater runs continuously at 50% of capacity. So when you're installing a hydronic heater on board, make sure that you go through the time of thinking, what are going to be all the bends, and that the airflow can go unimpeded to the outlets, okay? Here's a little bit about, the reality is that, unfortunately, over time, there's always a sort of a water layer that accumulates in our diesel tanks through condensation. It's just a reality, right? The tanks aren't always full. You're going to have condensation inside the tank. The condensation, the water and the fuel, where they meet, there's going to be a layer of sort of microbes that live there. And over time they die, and that's that sort of sludge that comes at the bottom of the tank. I remember years ago, my heater would stop working on a crossing, really bad crossing, 30 knots, like it was like a laundromat. And when we got to the anchorage in the middle of winter, December 23rd, the heater wouldn't work. It worked at the dock before we left, but didn't work when we got there. And I was like, well, that doesn't make sense. Why would the heater stop working? It was working this morning, last night when we slept on board, but now it stopped, and it starts, but it just sort of, there's an issue. And sure enough, I was like, oh my God, we were sloshing around all that sediment in the tank. And I went to the fuel filter, and it was completely clogged up. I felt like such a hero, saved the day. And then my partner reminded me, why do we have so much sludge in the diesel tank? Weren't you supposed to clean it before last year? And I was like, yeah, you're not supposed to remember that. I had a win for a moment there. So that's another, unrelated to diesel heaters, but you want to make sure if your tanks haven't been cleaned in a long time and you're thinking about adding a diesel heater, make sure that the fuel pickup line doesn't go to the bottom of the tank. And if you're in your really bad sea state and you're being bounced around and you're running the heater, you're going to probably end up having sediment going up, clogging the filter, and then you're going to have to undo the filter, clean it out, and let the sediment go back to the bottom, okay? Or what you should do is clean your tanks more often than we like to do. It's expensive to do that, right? But there are services that do that. I've done my boat for 14 years now, and I've had my tanks cleaned twice. And I always keep my tanks as full as possible, but it's just a reality. There's always going to be some sort of water in your diesel tank, and water with diesel fuel causes these microbes to live, and then they die, create a sludge, and then they're in the bottom of your tank. So the rule is when you're installing a fuel pickup, the distance between the fuel pump and the heater is it can pull for 6, can push for 20, and it can rise 3 feet. The other thing too that I've heard from service technicians is that people will end up buying a bigger heater, looking at the pump, they look the same, leave the pump there thinking, don't need to change it, this becomes a spare. But what they don't realize is every single pump is tailored for a specific flow. It's a metering pump. It's the exact flow rate that the heater needs. So when you change the heater, change the pump, okay? Here's another big takeaway, especially for heaters as well. A heater is one of those things that breaks the rules for electrical systems, meaning it's an always-on battery connection. On a boat, there's not too many things that should always be on, meaning that when you turn the battery switch off, things are still working. Bilge pumps would be an exception to that, right? Bilge pumps should be on even with the battery switch off. Your carbon dioxide, if you have one on board, would be unswitched, meaning even with the battery switch off, that's still going to be powered. Stereo memory, unswitched. Otherwise, every time you turn the battery switch off, you lose all your settings in your stereo. Another one of those devices that is unswitched as well, and that's really important, is your heater. Your heater can never, ever, ever, black and white, be disconnected from power suddenly without cooling down. It needs to go through a cool down process. So all heaters should bypass the switch and go directly to the battery via an inline circuit breaker. So even if you are having your heater, you're on board your boat, you're running your heater, you're doing maintenance, you decide to shut off the battery switch, your heater cannot be powered from the switch side of the battery switch. If you do that, the heater's not going to go through a cool down process, and you're probably going to permanently damage your heater. Okay? Honestly, most techs that install heaters know that. I'd say 99%. So it's not an issue. But if you're ever rewiring your boat, and you're like, well, that's stupid. Why is my heater on the unswitched side? Let me put it on the switch side of the circuit. And you accidentally one day turn off the switch while the heater's running. Your heater's not going to go through the cool down process, and then you're probably going to damage your heater. The other thing too, a big takeaway, and I see this all the time, and it's not so much related to heater, but it's related to magical heaters. What's a magical heater? A magical heater is a heater that does not draw power. And I get this all the time. People say to me, Jeff, look at my battery monitor. My battery monitor, I don't draw any power when my heater's on. I'm like, listen, I want you to have what you want. But there is no such thing as a magical heater. Your fans aren't powered by diesel. You know, the thermostat is not powered by diesel. There are electrical components on your heater. What you mean to say is that the person that installed your battery monitor didn't understand that the negative from the heater should not bypass the battery monitor shunt. Generally, I get called on those boats and the batteries are dying prematurely. And they're like, I don't understand, my batteries are dying prematurely, but luckily they tell me my heater doesn't draw power. I'm like, it's actually related. Your heater draws power, you don't count it in your battery monitor, your batteries are dying because you're drawing them down, but you don't know that because your heater bypasses the shunt. So it's very important to have the positive connection go directly to the battery, but the negative connection has to go on the load side of the battery monitor shunt. And I cannot tell you, if you have a battery monitor and a heater on your boat, 80% of you have the shunt not properly wired. because people just are following the directions from the heater manufacturer, and the heater manufacturer doesn't now know you have a battery monitor, and so they're like, well, they're both doing what they're being told to do, but they're not understanding that both products are working together, okay? So make sure if you have a battery monitor on board or you have a heater installed on your boat, make sure that it draws power when you're running your heater. If it doesn't, it tells you right away that someone bypassed the shunt, okay? Here's what the exhaust, and I wanted to show you, see how it's double walled? You have sort of, that's the exhaust that's going to get really hot, but the hull's never going to see that because there's actually an air gap between the really hot exhaust and actually what's going to be touching or near touching the fiberglass. In the past, they weren't doing that, and the exhaust, you would actually see tarnishing. On my boat, that's what happened. My heater was probably installed in the 1990s, and you had actually yellow tarnishing of the fiberglass. You couldn't see it, but as soon as you removed the through hull fitting, you actually saw that the fiberglass got really smoking hot. Nowadays, what they're doing is they're putting these double walled outlets. Now, here's another thing too. You'll notice there's a sort of an angle there. Especially if you're a sailboater, the exhaust should actually go up and have a gooseneck and come down again, right? You never want water. Sometimes waves come, even on a power boat. You know, waves are not always sort of below the waterline. Waves do hit our boats, and when they hit our boats, we hear them, and sometimes it's scary. Well, that force of water coming in, if you've got your outlet, the highest point of your hull, right, but not the superstructure, and it's this high, and you simply have it go down, you could literally flood your heater. So you have to have it go up and down again. So you need a gooseneck on your exhaust, and that's why this exhaust has already sort of that bend to it, because it's already coming in, you face that going up, and then you have it going down again, okay? And then you're probably wondering, well, how do I make sure that exhaust doesn't move around? You have offsets that you install throughout the boat to make sure that even though it's pretty rigid, you never want a warm exhaust, even though it's wrapped, touch fiberglass, right? Because they get pretty smoking hot, especially the hydronic ones. I was trying to I couldn't get a really high res picture, but it gives the drift of, you see sort of a Y, right? So that's sort of how you get one heater outputting one outlet, because a airtronic only has one outlet, pretty big, 3-inch, 4-inch. You get it, and then you start separating it out, right? To 2 outlets, 3 outlets. But again, remember, hard bends are a big problem, right? It's like anything. It's like a river. The moment a river hits a 90 degree, I mean, there's huge amount of erosion on that side of the river, right? Hard bends are hard for everything. So generally, you want to have as soft a bend as possible. Now, that's easy to say, but on a boat, hard to do. I mean, we have all these physical constraints on our boats, and so it's a challenge, again, with those ducting, right, of getting these soft bends to not limit the rate of airflow coming out. Troubleshooting tips. If you've got lots of gray smoke coming out of the exhaust, then it's probably a sign that you have actually a combustion problem, which is generally a sign that you probably have the fuel filter flog, which is generally a sign that you had too much sediments in your tank. Check the fuel filter. Fuel filter is actually right here, the little screen. Now here's a really important thing. Never, ever, ever, ever black and white, especially on the S-bar ones, loosen this at the top. If you loosen the outlet of the pump, you're actually going to need to have it brought back to the shop. They'll need to change it. It's actually done at the factory, and that's what decides precisely the flow that's coming out. So when you loosen the bottom, never loosen the top. If you do loosen the top, then the metering, the exact metering that you need for your pump won't happen, okay? Another thing too that happens a lot of times is people, remember, our battery voltage is not perfectly steady, right? And over time it drifts and it goes lower and lower and lower the longer we're at anchor. Or if it's a bad battery, it goes there quickly. What that means for you as a boater is, a way to troubleshoot is, if your heater runs no problem when you're connected to shore power, which means you're have a battery charger on, that's generally a problem of your batteries becoming weaker, right? And the heater dies. It's not that the heater's problematic, is that your batteries are being drained. And if your battery monitor's on board and it's being bypassed because it wasn't installed properly, it's sort of like making decisions in the dark, right? So it does happen where people are blaming the heater, but what it comes down to is that the battery that's powering part of the heater is getting weak. And if you have bad connections, long lines, then it makes it worse and worse because of voltage drop. So try it at the dock. If everything runs well at the dock with the battery charger on and you're at 13.5, 13.6 volts on a 12-volt system, then that tells you that the problem is a battery problem. It's not a heater problem. It means that your batteries are either weak or there's too much voltage drop on the line, okay? And a big warning, never disconnect power on a heater when it's operating. So even if you'll see a little circuit breaker, generally close to the battery, never press that on or off or disconnect the heater when it's running, ever. Because I said it's going to cause, there's no cool down process. If there's no cool down process, the heater's going to be permanently damaged. So next what we're talking about is hydronic. This is the D5. You can see the 17,000 BTUs, British thermal units. Up to 3 heat exchangers, 5 heat exchangers. I'll show you examples of that. Here's an example of an M2 D10. You see that's the coolant pump at the bottom. I'll show you a little bit. This is a breakout of what it looks like. So you got this water pump, right? Some of them can be external. So with a hydronic system, what you're doing is you're saying, okay, I'm realizing the constraints of having airflow on my boat. I've got a bigger boat, and I need to have all these different places on my boat warmed up at different temperatures. Maybe you want the salon warmer than your, I don't know, you're the VIP cabin or another cabin on the boat or the galley or the flybridge. So with a hydronic system, you can start having multiple thermostats, multiple zones. Like on some boat, we have 4 zones, 5 zones. And what you're doing is you're circulating all that heat throughout the boat via coolant, via these sort of pipes about this big in diameter, and it's a loop, right? Goes one in, one out, one in, one out. And again, same sort of fuel coming in, air coming in, exhaust. Now this sort of, I'll show you what the exhaust looks like. In the marine, it's a little bit, you can't really put those in. They're about this big in diameter. So you'll have a silencer. And again, it's very important that those outlets for exhaust are at the aft of the boat. Ideally facing aft so that if there's wind coming. But again, be careful here in the Pacific Northwest. A lot of us end up stern tying, right? We stern tie. So you stern tie, but sometimes the wind's not always coming from the front when you're stern tying. You could have the wind coming from the aft. If you've got an exhaust coming from the back of your boat and the wind's coming from behind you, it's very likely that that wind's going to go through the companionway, through the door, and you're literally going to have carbon monoxide poisoning inside your boat. I never, ever, I am super paranoid. I will never run my heater on my boat at night when I'm stern tied. I'll control it in the daytime because I know where the wind's coming from, but sometimes there's wind shift changes. You're stern tied, and now suddenly, in the middle of the night, it wasn't supposed to happen, the wind's coming from behind. And now the wind's blowing in your boat from your cockpit, and it's blowing literally exhaust fumes inside of your boat. And it's a silent killer. So as a rule of thumb, I never am stern tied and running my heater at night. And as much as possible, if I'm running my heater, I want to be swinging at anchor. So the wind's always coming from the bow, the wind comes, and it's blown away from the boat. Sort of a little hydronic, you've got an exhaust. Simplified a little bit here. You got a header tank, and there's also missing here, there's also an expansion tank. These fan matrix have different names. We'll talk about that too. These hydronic fan heaters, right? And this is how coolant is plumbed in and out. And then you have some heat exchangers or fan heaters have 1 outlet, 2 outlets, 3 outlets, and they're all made for different sizes. Some of them have crazy BTUs. Like for example, on my boat, I've got a bigger heat exchanger for my cabin, like my main salon and galley, than I do for the place where we sleep in our sleeping cabins, right? I only need a small heat exchanger for there because I don't need it that warm. But in my main cabin, I've got a big Skookum heat exchanger. When I turn it up, I can warm up my cabin very quickly, right? So I have a Catalina 36. I have 4 heat exchangers on my boat, right? I have some that I have sometimes I only use to warm up the boat really quickly. And then after that, they're just generating so much heat, I actually put them to sleep. I turn them off. Coolant's still going through them, but I'm not drawing heat from them. Because sometimes I want to warm up the boat quickly. I don't want it to take 2, 3, 4 hours to warm up the boat. I want the boat to be warmed up as fast as possible. All these fans can be controlled obviously via thermostat and also individual fan controls, like high, off, low, right? So there's a little bit to control some of the heat coming off of there. The other big important thing to notice, and why a lot of people end up doing these hydronic systems, is that you can actually integrate them directly into your existing hot water tank. Marine hot water tanks can be powered by AC, right, with an AC circuit breaker, meaning the generator or shore power is available. Or you can actually, there's actually an in and an out for coolant. You can have those plumbed to your engine, right, via the auxiliary. So you can actually have a coolant loop. So when your engine is running for propulsion, you're also warming water in a marine hot water tank, not via AC, but via coolant. Or you can run them through a hydronic heating system. Meaning you could be at Anchorage and literally have your hydronic system on. The engine hasn't been on for 3 days, and you're literally having the coolant that's coming from there go through your basically hot water tank. So you have hot water pretty much in the winter. I've got hot water all the time because my heater's running all the time. And so there's always coolant going through the heater, okay? And you don't need to have the main engine to be connected to the hot water tank. If you want both, you'll need valves, because you can't have two things connected to one thing. So you'll need to have Y valves. Decide, am I going to run hot? Am I going to warm my marine hot water tank via my engine, propulsion engine, or via my hydronic heating? So these hydronic fan heaters, you're going to choose them based on BTU size. Physical size means, remember, this is a boat. You don't do what you want, you do what you can, right? There's a lot of places you can't fit that heat exchanger. You want to fit a heat exchanger this big in your head, it's not going, where are you going to mount it, right? You end up doing what you can. So there's sort of the wish list, and then there's reality, right? And you can get creative, but you can only get creative so much. It's a physical space that has tons of constraints. On some boats, we can only fit a heat exchanger, fan heater like this big. That's it. Some other places we can get a big one like that. It depends on where it's going to be mounted. Sometimes you don't mount it where you want it. You mount it where you can. Okay? And the number of vents that you have. Also, a big takeaway there is, because power is limited on a boat, especially battery power, you also have to remember that you'll want to make sure you get fans that are efficient with power consumption. On my boat, if I have all my fans on high and I'm running everything at the same time, my heater can draw up to 15 amps at 12 volts. That's a lot. My fridge only takes like 4. That's 4 times the power consumption of my fridge to heat my boat. Now, my heater doesn't run 24/7. It comes on and off. And then sometimes I might make my fans in low. If I'm really sort of being draconian, I might turn off some heat exchangers. Like if we're out at an anchorage for 3, 4, 5 days, I might not warm a cabin that we're not going to spend time in. You know, like for example, we sleep in the aft cabin. My forward cabin has a heat exchanger. I'm going to turn that off. I'm not there most of the time. I close the door. I'm not going to heat a room I don't need and have a fan turned on drawing power, because maybe I have a lot of diesel. I'm not too worried about diesel, but I don't have enough of battery power. So that's what basically a single fan heater looks like, right? And you can buy them in single, double, triples. Here's another one too here, surface mount. I have one like that in my boat. Literally I've got a cutout, it's about this big, and the heat exchanger is right behind it, and it's blowing fan. There's not a small outlet. The outlet is literally almost that size, right, in the main salon. Here's a dual fan heater, right? So you could, for example, very commonly, like we did that on another boat, we'll install one in between, let's say, a cabin and a head, and one outlet's going to go in the head, and the outlet is going to go in the cabin. On my boat, I have one beneath the aft cabin. One goes in the galley, one goes in the aft cabin, right? Because you can't put, I mean, ideally, you'd want to have a heat exchanger for every single room, but again, it's not money. It's where are you going to put all this stuff? Like, even if you have endless money, if you have a normal sized boat, you're like, and even a 70-foot boat, it's still hard to put heat exchanger. Where are you going to put them? There's not these cavities everywhere that are just, oh, here you go. There's an empty cavity that nobody ever thought about using. On a boat, that doesn't happen. It's like empty cavity, there's a drawer. Empty cavity, there's storage. People are thinking about using space all the time. So Remember in the other slide, this is an essential part of a hydronic heating system, and you've got this expansion tank. You can buy them either vertical or horizontal. And you'll notice here, this is where you're going to have an overflow tank. You see this little nozzle here and here? That's connected to this overflow tank. Remember with anything hot, it says that on the cap, but you can never open that up when it's warm, of course. It says right on the cap, so you got to wait. If you're going to service your heater, you got to wait for it to cool down, right? Because this is going to get pretty high pressure in here when it's running. Overflow tank. This is a picture of a coolant. Some heaters have the coolant pump integral in part of the unit. Some have it external, right? But that's, because remember, your diesel heater warms up coolant. But I mean, it's one thing to warm up something. You have to then start circulating throughout the boat. And so you do that with a coolant pump, okay? And that's the pump that actually circulates all the coolant throughout the boat. Same with the hydronic, you've got different thermostats, but here's where it gets interesting. You have these aftermarket sort of boards, right? The ability of controlling multiple zones. So you could say, I want my head to be warmer than my cabin, but I want my flybridge to be so-and-so temperature. You can actually have the heater turn on and off individually for different zones. So if all the zones are off, the heater's off. You turn one zone and you say, I want this zone to be at 72 degrees Fahrenheit. I want this zone to be at 78. If no heater's on, the 78 is going to see, I need heat. At 72, the other one said, now I'm going to only turn on the fan. The heater's running, and I'm going to have the fan running. So they're both deciding if they should turn on the fan, and if there's not enough heat in the system, they're going to turn on the heater as well. So you're literally controlling all these different zones on your boat, which is nice. That means that you don't have to have everything warmed up all at once at the same temperature. Because what happens is you might have a thermostat in one part of the boat, right? And then that place gets hotter sooner than somewhere else. And so you might have cool spots and hot spots. The way to do that is to have multiple thermostats. Sounds great. Downside is it costs more money, it takes more time, right? So it depends on what you want to do. Easy is one thermostat, and whatever temperature is at that thermostat is the temperature that the heater is going to stop working. So you might increase the temperature there and have it warmer in some places and to make it less cold in others, right? So that's why I like to have multiple thermostats on a hydronic heating system so that everyone can have the temperature they want, where they want it. So the takeaway here is, when we're installing, the first conversation, let's say for example for that Alaska owner, never saw the boat, got blueprints of the boat, we said, okay, well how many heat exchangers we're going to put on board, right? That's the first question. What do we need to warm up? Do you want to warm the flybridge? Do you want to warm up both? You've got 3 cabins on board. Are we warming up all the 3 cabins? Yeah. Are we warming both heads? Yeah. Are we going to warm up the galley, the salon? Yeah. Then you start, okay, all right, so now where are we going to put those heat exchangers? And there's what you imagine and what's going to fit. Because before you start, and then you got to measure, okay, here's the one I'm speccing out. Oh yeah, where the hell am I going to put that? Can't do that. That's not going to work. And then that's where you got to go back to the drawing board and start getting creative in your selection of these air handlers, right? To figure out which ones are going to work. And then you decide, okay, well then where am I going to put the thermostat? Because if you've got a heat exchanger that's doing the head and the cabin, well, where's the thermostat? Is it in the head or is it in the cabin? You can't have a thermostat in both places, right? Because it's controlling one heat exchanger. The other thing too that can be very frustrating with a coolant-based or a hydronic-based heating system is the reality that you've got this coolant loop, but if ever there's airlocks in that can give you a lot of grief. I learned years ago the best way is to not hope for that coolant pump to be able to remove all those airlocks. What we end up doing before we even put any coolant in it, we actually connect city pressure water, like 50 psi, literally in the system, and we blow literally just simply normal water right through the system. We get all the airlocks out. At this point, it's going to work. I can guarantee. Remember, in life, there's hope and there's reality. Hope never pans out. That's why I don't play the lottery. I don't hope. I just plan. I'm like, I got people, installers are like, oh no, we're going to try with the coolant pump. I'm like, you're wasting your time. Remove the airlocks, connect it to city water, right? Make sure there's water everywhere. Once it's out, Then what we end up doing is we run a separate pump, not even the coolant pump, and now we got a big bucket, and now we start pumping coolant via separate pump through the system, make sure that everything's good, coolant's coming in, it's all even, right mix, and then we hook it up to the heater and to the existing coolant pump. And then when we light it up, it works. Hope. There's no place on a boat. Don't do it. You're just like no shortcuts. You try to do a shortcut, you're banging your head against the wall 2-3 days, and you're like, oh, maybe I should have done that at the beginning. Okay? So bleeding is a big issue. And what we end up doing too is we end up putting valves everywhere at the high points. So like really good heat exchangers are going to have bleed valves everywhere. And at every high point in a hydronic system, we put a bleed valve. So that you can actually, if there is an air pocket there, you can actually bleed it out. We talked about a little bit about the gooseneck for the heat exhaust, right? To make sure that before it goes outside of the hull, it's got to go up and then down and out. And then the length of the exhaust can only about be 6.5 feet. So that's a challenge. That means the heater can't be, in most cases, installed in the middle of a boat, right? It's got to be installed on port or starboard. And you got to figure out your exhaust run, right? And the other thing too is if there is a little bit of water that's going to get in, and there's normally some water that gets in just from condensation, it's actually going to drip through this little contraption here, okay? And that's at the bottom of all the exhausts. So with that, I'm going to open the floor to questions. Anybody have any questions on marine heating systems? Yeah, go ahead.
On the small air heaters, what's the maximum startup current?
Yeah, I don't think it's that much. It's maybe about 6 amps, depending on the size. I don't.
Startup?
Yeah, 6-10 amps. Not that much.
What's the lifespan of those heaters?
The airtronic 5,000-6,000 hours.
What usually goes on?
Generally, ceramic glow plugs, I've heard. Fuel pumps. Yeah, and you know what? There's, depending on the company you choose it from, there's people that actually have service departments, like Roton, for example. They do their own servicing of SPAR. And there's a guy that full-time just does, some heating are 20-year-old heating systems. They come back, you bring it to the bench, they'll be able to change some parts, right? Yeah.
On a hydronic system, what's the typical temperature?
Oh, and the question is, what's the typical temperature of a hydronic heating system? Oh my God, it's really warm. I don't even know, but scalding hot. Like it's like freaking hot. Like you can't, like you would get burnt. So 200 C or something, I don't even know. I have no idea. I'm guessing. It's freaking hot. Freaking hot. It's definitely over 100. I don't even know what it is. Yeah.
We'll be looking for that.
Okay, thank you. Anybody else? Any other questions? Anybody here in the room have a heating on board? Thinking about it? SPAR? You have a heater?
No, not yet.
Not yet, thinking about it? I mean, just in closing, I think the consideration is if you want to extend your boating season beyond the really warm months, or you want to go further north here in the Pacific Northwest, for us and for the boaters we've done it, it's a way to sort of extend the cruising season. You know, like sometimes in May and April, it's gorgeous. Sometimes in September and October, it's gorgeous. Without going crazy, like not that many people boat in December, like I do. But even the shoulder months before the peak season, those would be the arguments. And also if you're going up north. If you're going up north and you pass Desolation Sound where the summer ends, once you go in Discovery Islands or Browns or outside of Vancouver Island, then the weather drops by about 10 degrees Celsius, even in the summer. And that's where there's an argument to consider heat. But you don't have to. Yeah.
Can you say anything about the relationship between heating, venting, and condensation?
Oh yeah, that's a really good question. Really good question. What is the correlation or relationship between heating a boat and condensation in a boat? And that's a great question. Most of our boats are not really well insulated, right? I mean, it's a hull. And to avoid condensation on a boat, you should avoid eating it. The moment that you increase the temperature of your boat beyond the temperature of the water around our boat, so if the water is at, let's say, 50 degrees Fahrenheit or 10 degrees Celsius or whatever that is, the moment you warm up your boat beyond that and you don't have really good insulation, your boat will weep. it will be crazy. Crazy amount of condensation. The water temperature is 50 degrees and you're heating your boat at 75. That's 25 degree is going to cause your hull to weep like there is no tomorrow. So on our boat, when we do that, because in the wintertime, the water temp might be 50 degrees Fahrenheit and inside is 70, we actually open the windows dramatically on our boat. You have to let it out. Otherwise, it becomes almost a sauna. Like the amount of condensation that happens is everywhere. If you don't see it, open somewhere and you'll find, like literally, I'll have pools of water. So there is no way around that because we don't have our hulls well insulated. Hence, when I'm not on my boat, I don't keep my boat at 70 degrees Fahrenheit if I'm not on the boat. I keep it slightly warmer, only slightly warmer than the water temp. So I warm it, but just not by much. Otherwise, what you're doing is you're losing a battle. If you're keeping your boat at 70 degrees Fahrenheit and the water temperature is at 50, the very thing you're trying to avoid, which is condensation, is what you're creating. You'll never be able to solve it because the water around you is at 50 and you can't warm the ocean. And it's cooling your boat faster than any heater, than anything you could ever do, and it's condensating, and then you'll have water pooling everywhere. And that pooling is causing moisture, and then you're fighting that moisture by heating, and you just can't win. You can't win. Any other questions? Thank you everyone for taking the time to be here. And if you've got further questions, I'm going to be upstairs at our booth. Thank you.